This is my Precalculus course. Today we're going to learn parametric equations. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Here's a formal explanation of parametric equations, but it's easier to just do an example problem. Parametric equations are used when the x and y values of a graph are dependent on a third variable, which we call the parameter. And the letter that we use most commonly for the parameter is t, because in real-world examples, t is often time. One of the most famous applications of parametric equations is projectile motion. When an object is shot up into the air, the horizontal and vertical movement is described with parametric equations because the horizontal and vertical movement is dependent on time. So here's an example of parametric equations. We have an equation that defines the x values of a graph and another equation that defines the y values of a graph. So we're told here to write the coordinates of at least 4 points and to use a graphing calculator to help us. And we're going to graph the parametric equations, and then we're going to do something called eliminating the parameter. So I want you to get your graphing calculator and press the on button. And then I want you to press the mode button if you're using a TI-84 Plus. Press the mode button at the upper left, then the down arrow key, and see where it says function and parametric and polar. It has abbreviations FUNC, PAR, and POL. In the previous class we were in polar mode where it says POL, but now we're going to change to PAR, parametric mode. So press enter on that. And make sure parametric is highlighted. And for angles, we should be in degree mode, so make sure degree is highlighted. Then press the blue second button and then the mode button again to quit out of that screen. Then I want you to press the y equals button at the upper left, where it says stat plot F1, y equals button at the upper left. And notice now, instead of R1 and R2 and R3, for polar equations, it says x1 and y1 and x2 and y2 and x3 and y3 and so on and so forth. So we're going to enter our parametric equations. So for x1t, I want you to press the x, t, theta, n button. So that's the variable button. It should look like this. It's right under the mode button. And when you press that button, it's going to give us a capital T in this equation here. And you can use the up and down arrow keys to help you get from one equation to the other equation. And then I want you to enter +1. So for some reason the engineers chose to use a capital T rather than a lowercase t, but just be aware that the parameter, or that the letter used for the parameter, is almost always a lowercase t. So then I want you to push the down arrow key and go to the next equation, y1t, and you're going to press this same button again. And then you're going to press the upside down V button, which is under the clear button at the middle right. So the upside down V button is the exponent button. And then you're going to enter 2. So you should have t squared. So this is what you should have for your parametric equations. And I got that from here. And I got this equation from here. So x is defined by t plus 1 and y is defined by t squared. So now we're going to make sure that our window is correct. So we're going to press the window button right next to the y equals button. It's the table set F2 button, the window button at the upper left. So notice it says T-min and T-max. So those are all the possible values for your parameter T. So you can enter -10 for T minimum and +10 for T max. That's probably going to be good enough for us. Now T step is the interval for each T value. I want you to enter 0.1. So it's going to plug in T values that are 0.1 units from each other. So the smaller this value, the more smooth your graph is going to look. The bigger the value, the more disjointed it's going to look, or jagged, whatever word you want to use. Not really disjointed, but it's not going to look very accurate. So we should have T minimum -10, T max 10, T step 0.1. So notice down here we have 4 units to the left of the y-axis. So we want x minimum to be -4, and x maximum we want to be 3, and the x scale is going to be 1, y minimum is -2, and y max is going to be 5. We can see the x min, x max, y min, and y max based on the window that I gave you for your graph here. So I'm going to go to the top of the screen, and I want you to go to the top of the screen, and we're going to make sure we have this entered in correctly. So T minimum is -10, T max is 10, T step is 0.1, X minimum is -4, X max is 3, X scale is 1, Y minimum is -2, Y max is 5, Y scale is 1. Okay, so now we're going to press the graph button at the upper right where it says table F5. Push the graph button, and your graph should look something like this. And notice that if you saw when it graphed, it actually started from this side and went to the right. So that brings us to an important point. Why do we use parametric equations? Well, again, x and y are sometimes dependent on a third variable. That's the primary reason. But we also use parametric equations because if you were to graph some equation, let's say y equals x squared, your graph would look like this. But there's nothing that tells us the sequence in which we have to graph the points. This point doesn't have to come before this point up here. But when you have parametric equations, it's assumed that the points that have the smallest t values are graphed first. So, for example, if t represents time, I would start by plugging in 0 for t, and then t would get bigger and bigger and bigger as time goes by. So the graph actually starts from the left and then goes to the right. So that's one purpose for parametric equations. It gives us a sequence that we plot our points. Again, this is something that we can use with things like projectile motion. As an object flies into the air, we can track its path according to time, or based on time. Another reason for parametric equations is that sometimes these equations can put limits on x and y, and that's important in certain contexts. So we have the graph in our calculator, but we need to know how to plot points without a calculator. So that's what we're going to do now. So I want you to find 4 points by doing the math. So the first thing we're going to do is choose our value for the parameters. So I'm going to choose t equals 0. Then we're going to find x, and we're going to find y based on our choice of parameters. So I got this equation from there, and I got this equation from there. So x is going to be 1, and y is going to be 0. And so that is our first point that we're going to plot, 1, 0. So there you go. And that's how this works. Now we choose a different value for the parameter. So x is equal to 1 plus 1, and y is equal to 1 squared. So again, I got this equation from there, and I got this equation from there. So x is equal to 2 and y is equal to 1. So the point that we're looking for is 2, 1. So that's that point there. And now let's choose t is equal to -1. Again, we choose our value of the parameter first. So x is equal to -1 plus 1, and y is equal to -1 squared. So again, I got that equation from up there, and I got this equation from there. Now remember, when you square -1, you have to use parentheses. If you don't use parentheses, then it's not going to be a correct expression. So y is 0, or x is 0, and y is 1. So our point on the graph is 0, 1. Okay, and now we're going to choose, let's say, -2. We'll try -2. So x is equal to -2 plus 1, and y is equal to -2 squared. I have the parametric equations here. So that means that x is equal to -1 and y is equal to 4. So -1 comma 4 is the last point. So let's plot that. That's going to be actually there. So as you can see, this is a parabola. We can use symmetry and go ahead and draw that. So it's a parabola, and that's how we plot the points using parametric equations. So we drew the graph and we found 4 points on the graph. Now we're going to eliminate the parameter. So I redrew the equations down here. To eliminate the parameter, we choose one of these equations that is easiest to solve, t. And you can see that it's going to be pretty easy to solve t with this equation, or to solve for t. We want to avoid square roots. So t is equal to x minus 1. And then we're going to go to this equation and rewrite it. But instead of t, we're going to write what the other equation tells us that t is equal to. So I plugged that in for t. So now we've eliminated the parameter. This equation here is the same equation that we just graphed, but there's no t values. Now you'll probably wonder, why don't we just use this equation? Why do we have to use parametric equations? Well, again, parametric equations make it to where x and y are dependent on a third variable. If we write this equation, there is no third variable involved. And you're going to see how a third variable changes things as we continue through the class. So notice that this equation down here doesn't have any t values. That's what it means to eliminate the parameter. T is the parameter. If there are no t values left in the equation, then that means we eliminated t. We eliminated the parameter. So again, this equation here completely describes this graph. Let's go on to the second problem here. We'll start by graphing. So go to your graphing calculator, press the on button at the bottom left, press the y equals button at the upper left, and press clear at the middle right to erase those equations that you already have in there. And then you're going to push the variable button, x comma t comma theta comma n, and then the upside down v button at the middle right, and then 3. So you should have x1 t is equal to t cubed, and y1 t should be equal to capital T minus 2. So press the down arrow key to get to the next equation, and you're going to push that variable button again, and then minus 2. So then you can push the window button, the table set F2 window button at the upper left next to the y equals button, and let's change x minimum to -10 and x max to +10, and y minimum will go to -9 and y max +9. So if you go to the top of the screen in your window button, you should have t minimum -10, t max 10, t step 0.1, x minimum -10, x max 10, x scale 1, y minimum -10, y max 9, and y scale 1. If you have a problem graphing these equations, then the problem is probably going to be in your window. You probably entered something wrong in your window. A lot of times students enter n minimum as a positive number and x max as a negative number. They accidentally reverse those, and that's one way that you can have a problem. Your graph will get confused by that. So if you have a problem graphing, it's going to be probably your window which is causing the issue. But it's also possible that you didn't enter the equations in correctly, so you can press the y equals button and check that. So now at the upper right, we're going to press the graph button at the upper right, and we see that we have a graph that looks something like this. But we're going to plot some points manually. So let's try t equals 0. We start with a value for our parameter. We always start with the t value. So x is 0 and y is -2. So that's our first point that we're graphing. So let's try a different t value. Let's try t equals 1. So x is equal to 1 cubed, and y is equal to 1 minus 2. So x is 1 and y is -1. So that's another point. And let's try maybe -2 for t. So x is equal to -2 cubed. Be sure to use parentheses. If you don't use parentheses for that notation, then you're going to get it was just the wrong language that you're using. Okay, so if we choose -2, we get -8 and -4. So let's plot that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. And let's find one more point. Let's choose t is equal to maybe positive 2. So x is equal to 2 cubed, and y is equal to 2 minus 2. So x is equal to 8 and y is equal to 0. Our next point is 8, 0. So let's plot that. So that's about there. And then we can connect the dots. The graph doesn't have to be perfect, but it looks something like that. So if you got that graph on your calculator, good job. Again, if you're having a problem graphing that, press the window button, and it's probably going to be something to do with your window. And again, remember, you have to be in the right mode. You have to be in parametric mode. So now we're going to do what's called eliminating the parameter. So I have the equations rewritten down here. And we're going to get rid of t. So we're going to choose the equation where it's easiest to solve for t. And that's obviously going to be in the right equation. So t is equal to y plus 2. Then we're going to rewrite this equation, except instead of t, we're going to write what the other equation tells us that t is equal to. And so there you go. We eliminated the parameter, and now we have an equation with only x and y, and that describes this graph, just as the parametric equations describe the graph. But there's no limitations when it comes to x and y in this equation. But we are going to have some limitations depending on which parametric equations we choose in future problems. Okay, so let's do one more of these problems before you try one on your own. So I want you to press the y equals button and clear all of the equations that we did previously. And for the first equation, we're going to have a fraction. So I want you to go to the first equation and press the green alpha button. Then I want you to press the y equals button at the upper left. And if you push that button, then you should see where it says fraction here, then it says function and matrix and y variable and all that type of stuff. When you push these buttons, you should see a window come up. And 1, 2, 3, 4, I want you to press on n/d, which is number 1. So press enter on that. And when you press enter, you should see a fraction template. That's one of the most important things when it comes to using your graphing calculator, is knowing how to use that fraction template. So now we're going to enter t and 2. So again, use your variable button under the mode button. And I forgot to write the negative symbol in front, so you can use the arrow key to go right in front of that fraction and put a negative symbol in front of there, and then use the arrow key to go to the right, or you can just clear out and put the negative symbol first. Again, your negative symbol is at the bottom right where it says answer. Then it has a button with parentheses that say negative. That's your negative symbol. So at this point, you should have negative t over 2 in your first equation. And then for your second equation, of course, you should have just t. So go ahead and enter that in the second equation. Again, you're using the x comma t comma theta comma n button for the capital T. So now we're going to go to the window button, press the window button, which is right next to the y equals button, and we're going to change the x minimum is only going to be -4, the x max is going to be 3, y minimum is going to be -4, and y max is going to be 3. So your t minimum should be -10, t max is 10, t step is 0.1, x minimum is -4, x max is 3, x scale is 1, x minimum is -4, y max is 3, and y scale is 1. Press the graph button, and you should see what looks like a line. Now again, if you don't see that, if you don't see a line, then that means that there's probably something wrong with your Windows screen. You need to go back and change that. Or it might be that you entered the equations improperly when you went to the equation screen, the y equals screen at the upper left button. So now that we have that graph in our calculator, we're going to choose our parameter to be 0. That's always a good value to choose. So we have -0/2, and y is equal to 0. So x is 0 and y is 0. So 0, 0 is our first point. And now let's choose, I'm going to choose -2 because I don't want to deal with the fraction. So x is equal to -2/2. It's always best to use parentheses just to be safe when you have a double negative. So x is equal to 1 and y is equal to -2. So our next point is 1, -2. So 1, -2 is here. And now let's choose t is equal to +2. So now x is equal to -2/2 and y is equal to 2. So x is -1, y is 2. So we have -1, 2. So that point is going to be there. And you can see that this is just going to be a line. Now let's try x is equal to, we'll have to deal with the fraction though. So x is equal to -3/2, y is equal to 3. So that's our point, -3/2 and 3. So let's see if we can graph this. -3/2 and 3 would be about there. So again, you can see that this is just going to be a line. So we used our graph to help us, our graphing calculator to help us graph that. And we found 4 points, and now we're going to eliminate the parameters. So I rewrote those equations down here. We're going to choose the equation that's easiest to help us isolate y, and obviously that's going to be this equation. So we're going to look at the other equation and rewrite it, but instead of t, we're going to write what the other equation tells us that t is equal to. So now we have eliminated the parameter, and the graph of this equation is exactly that graph there. So I want you to take a picture of these two problems here, and you can use number 3 to help you. So you may need to change the window. So you're going to have to press the window button and change it based on this window here. And you're going to press the y equals button to enter in these new equations. And remember, the variable button is x, t, theta, n. That gives you your variable t. So try number 4, and when you come back, we'll do it together. Okay, we're back. So you should have those equations entered into your calculator. Let's find our first point. So I'm going to choose 0. You don't have to choose 0, but in that case x would be 0, y would be 3 times 0 minus 4, so x is 0 and y is negative 4. 0, negative 4 is our first point. So let's plot that. That's about there. And we can choose maybe t is equal to 1. And so x is 1 and y is 3 times 1 minus 4. So the points are 1, negative 1. And now let's choose, I think negative 1 is going to give us something off the scale. So let's choose 2. So we have x is equal to 2 and y is equal to 3 times 2 minus 4. So y is equal to 2. So we have the point 2, 2. And you can see that this is just going to be a line. So to make things easy, I'm going to choose t is equal to 1/3. So x is equal to 1/3. Y is equal to 3 times 1/3 minus 4. So x is 1/3 and y is equal to 1 minus 4. And so that point would be 1/3 negative 3. So let's plot that, which will be about there. So again, you can see that this is obviously a line. So if you got that graph, good job. You may have chosen different points, but as long as your graph is correct, that's fine. So now we're going to eliminate the parameter. We're going to start with the equation where it's easiest to isolate t, and obviously that's this equation because t is already isolated. So we're going to take this equation and rewrite it, but instead of t, we're going to write x, and there you go. So we eliminated the parameter. We had x based on t, and we had y based on t, but now there is no t. It's just x's and y's. That's what it means to eliminate the parameter. So if you got that graph and you eliminated the parameter and you have 4 points on that line, good job. So you can take a picture of this page here to help you do number 5, and you can take a picture of all this if you want. So try number 5. Remember, if you have a problem graphing the equations, then it's probably going to be your window where something is off. So enter those equations into your calculator and try number 5, and when you come back we'll do it together. Okay, we're back. So make sure that your window is correct. X minimum should be 1, 2, 3, 4, 5, 6, 7. So x minimum should be negative 7. X max should be positive 7, roughly. Y minimum should be 1, 2, 3, 4, 5, 6, 7. Again, Y minimum is about negative 7. Y max is about 7, we'll say. and press the graph button. So you should have a parabola that looks something like this. So let's try t equals 0 for our parameter. So x equals 0 squared, y equals 0 minus 4, x is 0, y is negative 4. That's our first point. So you may choose different points. That doesn't mean that you're wrong necessarily. So let's try t equals 1. So x is 1 squared, y is 1 minus 4, so x is 1, y is negative 3, so our point is 1, negative 3. And so there we go. So let's try another value for our parameter. Let's choose negative 1. So if t is negative 1, then x is negative 1 squared, y is negative 1 minus 4, so x is 1, y is negative 5. 1, negative 5 is our third point. So that's that point there. And what should we choose for our last t value? We could probably choose 2. So x is equal to 2 squared, y is equal to 2 minus 4, so x is 4 and y is negative 2. So our point is 4, negative 2. Let's plot that. 1, 2, 3, 4, 1, 2. And you can see that this is just going to be a parabola going to the right, or opening to the right, is how we would say that. So we have our 4 points. Now let's eliminate the parameter. So we want to choose the equation where it's easiest to isolate t. That's obviously going to be this equation over here. Then we're going to take the other equation and replace t with what the first equation tells us that t is equal to. So there we have it. So this equation down here describes this graph completely, but there is no t value. So we eliminated the parameter. So if you got that right, good job. So now try number 6, and when you come back, we'll do it together. All right, we're back. So you want to enter these equations into your calculator. I'm going to do that now. So I've got the equations, and we want to check our window. Make sure that your window corresponds to this this window here. And you should have something that looks like this. So let's find some points. We'll choose 0 for t. So x is equal to 2 times 0. Y is equal to 0 cubed. So x is 0. Y is 0. So we got 0, 0 for the point. Let's choose t is equal to 2. X is equal to 2 times 2, y is equal to 2 cubed. So x is 4, y is 8. The point we're looking for is 4, 8. And we're rectangling because our points are part of the answer. So it looks like that point there is going to be on the graph. Let's choose t is equal to negative 2. So x is equal to 2 times negative 2. y is equal to negative 2 cubed. So x is equal to negative 4, y is equal to negative 8. So negative 4, negative 8 is our third point. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So let's choose 1 for t. You may have chosen different points, that's fine. So x is equal to 2 times 1, y is equal to 1 cubed. So x is 2 and y is 1. Our point is 2, 1. So let's plot that. That's going to be there. So again, you can see that this is just a cubic graph. And when we eliminate the parameter, we should see that. So let's go to our equations here, and you can see that in the equation at the left, it's easier to isolate t. We don't want to have to deal with root symbols if we don't have to. So t is equal to x over 2. So then we can just go to the other equation and we rewrite it, but instead of t, we write what the first equation tells us that t is equal to, and we end up with that. You can simplify it a little bit if you want. You don't really have to, but we eliminated the parameter. There is no t value. So this yellow equation down here describes this graph completely. So if you got that right, excellent. Okay, so now we're going to do some more problems, but these problems are going to be a little different because now the parameter t is actually going to be restricted. T can't just be any value. And the reason for that is you can't have a negative under a square root symbol. So the smallest t value that's allowed with these parametric equations is 2. Any t value less than 2 and you'll get a negative number inside here. So that's one of the benefits of parametric equations, is you can define your x and y values so that there are certain limits on what they can be. So let's go to our calculator and press the on button at the bottom left if your calculator turned off, and press the y equals button, and we're going to enter the square root t minus 2. So push the blue second button and then the x squared button at the middle left, and you should see a symbol like this, and then press the variable button and then minus 2. So you should see this in your calculator for x1t. So then go down, and we have a fraction. So very important that you know how to use the fraction template. So you're going to press the alpha button, the green alpha button, then the y equals button at the upper left, and then you're going to press enter on number 1 where it says n/d, and that should give you the fraction template. Then you're going to press the variable button, the down arrow, and then 4, and then the right arrow. So you should see t over 4 in the second equation, t over 4. So now we're going to go to the window, and we see the window that we should have here. So make sure that all your numbers are in the right window. I'm going to do that now in my calculator. And notice that our t minimum is -10. at least my t minimum is negative 10 at the top of the screen, and my t max is 10, but none of those negative t values are going to work, and 0 is not going to work, and 1 is not going to work. No t value below 2 is going to work, but the calculator is just going to ignore those. So now push the graph button, and so you should get something like this. So let's find some points. So we're going to let t equal 0, but if we do that, again, we're going to get a negative under the root, so we can't choose 0. The smallest value for t we can choose is 2. So we have 2 minus 2 and 2 over 4. So x is equal to the square root of 0, which is 0. And y is equal to 1/2. So that point is going to be 0, 1/2. We'll plot that. And now, again, we can't choose t values that are less than 2. So now let's try 4. So x is equal to the square root of 4 minus 2. Y is equal to 4 over 4. So x is equal to square root 2. Y is equal to 1. So our point is square root 2, 1. So square root 2 is equal to 1.4. So we're going to go out 1.4 and then up 1, which would take us to about there. Now let's try t is equal to 6. So x would be equal to the square root of 6 minus 2. And y would be equal to 6 over 4. So x is equal to the square root of 4. Y is equal to 3/2. And we can obviously see that x is going to be 2 and y is 3/2. So let's plot that. That's going to be about there. And let's find one more point. Let's try t is equal to maybe we can try 11. So x is equal to square root of 11 minus 2. Y is equal to 11 over 4. And if we do the math, we find that our point is 3 and 2 and 3/4. So 3, 2 and 3/4. 1, 2, 3, and then 2 and 3/4. So it's that point there. Okay, that looks right. So now we just connect the dots and we have our graph. But what graph exactly is this supposed to be? So, well, we can figure that out by eliminating the parameter. So what we're going to do, again, is take the equation which makes it easier to solve for t. Obviously, we can do that in this equation over here. T is equal to 4y. Then I'm going to rewrite the other equation, and I'm going to replace t with 4y. So that is the equation. Now, in order to help us understand what the equation is going to be, because it's kind of difficult to see exactly what's going on here, we can square both sides, and now we see that it's just a parabola. It's a parabola going up. But here's a very important question that we need to consider. Why is there only half of the parabola? Why is the parabola cut in half? Well, again, that's because your parameter is limited. T cannot be less than 2. And so what that means is that your x value cannot be less than 0. 0 is the smallest possible x value. So by coming up with parametric equations for x and y, we're also limiting the values that x and y can be. And that's one of the benefits of parametric equations. But you should be aware that if you graph this equation, you would graph the entire parabola. There's no limitations on it. And it's probably best to use this equation because that describes the parabola better, because this equation is only part of the parabola. We'd rather use that to describe the graph. But even this equation here may not represent the graph completely, because there is no parameter considered here. So just be aware of that. Okay, so let's try another one here. So this is another example where t is going to be limited. Why is it limited? Well, because t cannot be 0. Then y is going to be undefined. So we can't choose 0, but we can choose 1. And let's enter this into our calculators first. So press the y equals button. And by now you should be able to enter this in pretty quickly. To use the fraction template, you push the green alpha button, then the y equals button at the upper left, then press enter, and then 1 over t. And let's go to the window. Make sure the minimum x is -4, max is 3, minimum y is -4, max y is 3, and then press the graph button. And you should get something that looks like this. So we recognize that graph. That's one of our parent graphs. That's the reciprocal graph. So if you plug in 1 for t, x is 1 and y is 1. So that's 1 point that we can use. If we plug in, again, we can't choose 0 for t, but let's try -1 for t. X is -1, y is 1 over -1. So x is -1 and y is -1. So the corresponding point that we're looking for is -1, -1. So let's graph that. And let's find another point. So let's plug in t is equal to, let's try -4. So x is equal to -4, y is equal to -1 over 4. So we have another point. About there. And let's choose t is equal to maybe 3. So then x is equal to 3, y is equal to 1/3. So our point is 3, 1/3. And so now we can connect the dots. We know that our graph is going to look like the reciprocal parent graph. And to prove that, we can eliminate the parameter. So we choose the equation where it's easiest to isolate t, and that's obviously the left equation. Then we write the equation at the right, but we replace t with x, and we can see that that's just the reciprocal parent parent graph and parent equation. But again, there are t values that are not allowed. In this case, 0 was not allowed. In this case, anything less than 2 was not allowed for t. So sometimes t is restricted. So I want you to get a picture of these problems and do number 9. There's restrictions on t. So I want you to look at these equations, and specifically the equation for y, and tell me what the restrictions are. Obviously t cannot be a negative number. So go ahead and enter those into your calculator, and when you come back, we'll do it together. Okay, we're back. So I'm entering these into my calculator, the equations, and we need to change our window. So I'm going to choose looks like -10 and +10 for x, and -10 and +10 will probably do for y. And I'm going to push the graph button, and it looks like we have something like this. So let's find some points. I can use 0 this time. X is equal to 2 times 0. Y is equal to the square root of 0, which is just 0. So we have our point 0, 0. And let's choose t is equal to t is equal to 1. So x is equal to 2 times 1. Y is equal to the square root 1. So 2, 1. And let's choose 4 for t. Again, you may choose different values. It's okay, as long as it fits on the window. So x is 8, y is 2. So 8, 2 is our next point. So 8, 2 is about there. And now let's choose, again, we can't choose a negative t value. So this value here, this x value, represents the smallest value that x can be. So let's see, maybe we can try 1/2 for t. So x is equal to 2 times 1/2. Y is equal to the square root of 1/2. That's actually not going to be very easy, but that's okay. X is 1. Y is the square root of 1/2, which is about 0.7. So our point is 1 square root 2 over 2 if we want to rationalize that, but you don't have to use that value. So that's going to be about there. So we connect the dots, and we see we have what looks to be half of a parabola. The reason it's half is because we have restrictions on what t can be. So now let's eliminate the parameter. So I can solve for t in this equation, and then I can take the other equation and plug in what t equals. Now it may be difficult to see what type of graph this is, so I'm going to square both sides, and now we can see the type of graph. But it's probably best to use this equation because this equation limits things. So we should have a parabola moving to the right And we do. But the problem is it's cut off. So the green equation does not cut anything off. The green equation down here will graph the entire parabola. But if you define x and y with these variables, then it has to cut off part of the parabola because t cannot be a negative number. Again, that's one of the benefits of parametric equations. It gives us limitations on the x and y values. And this can be used in the real world. So now we can't have 0 in the denominator here. So t cannot be -2. So try number 10. And remember, you can't choose -2 for t. When you come back, we'll do it together. Okay, we're back. So again, you want to use the fraction template. In your first equation, push the green alpha button and then the y equals button at the upper left. And then press enter on number 1. And enter 2, and then the down arrow key, and then t plus 2 using your variable button. Then press the down arrow key, and then t minus 1. Okay, then press the window button, and it looks like our window is going to be maybe x is equal to -7, y is equal to +7, and roughly the same thing for both x and y. So then I'm going to graph in my calculator, and you should see something that looks like that. So let's choose some t values here. I'm going to choose t is equal to 0. So x is equal to 2 over 0 plus 2. And y is equal to 0 minus 1. So y is -1. And x is 2 over 2, which is 1. So our point is 1, -1. Okay, so now we're going to choose t is equal to, I think I'm going to choose -4 this time. So x is equal to 2 over -4 plus 2, and y is equal to -4 minus 1. So x is equal to -1, and y is equal to -5. So -4 plus 2 is -2, and 2 divided by -2 is -1. So we have that point there. And let's choose t is equal to remember, we can't choose -2. Let's say maybe 4. So x is equal to 2 over 4 plus 2, and y is equal to y is equal to 4 minus 1, so x is equal to 2 over 6, and y is equal to 3. So 1/3, 3 is another point. So we have that point up there. And let's choose maybe t is equal to 6. So if t is equal to 6, then x is equal to 2 over 6 plus 2, and y is equal to 6 minus 1. So if we do the math, we find that x is equal to 1/4 and y is equal to 5. So 1/4 5 is about there. So our graph, I didn't draw that right. Our graph is actually going to look something like this, but it's hard to know exactly what it looks like. So it would be helpful if we could eliminate the parameter to see what type of graph it is using the equation. So let's solve for t in this equation. And let's plug in t into this other equation. So we have 2 over y plus 1 plus 2. So x is equal to 2 over y plus 3. So that didn't really help that much to see what type of equation it is, but we can see it's definitely a reciprocal equation, and this kind of helps us to see where the horizontal asymptote would be. So it's, if y is -3, x is not going to be defined, so your asymptote should be right around here. So that's very helpful to know. Okay, so there you go. There's your graph, if you got that right. Excellent. So we want to eliminate the parameter, draw the graph, and you should have 4 points. Let's rectangle this point. So in those problems, we saw restrictions. There were restrictions on what the t values could be. And in these problems we're about to do, we're not going to see restrictions on t. There are no restrictions on t. But because of the nature of these equations, there are going to be restrictions on x and y. So this is just another type of problem. So let's go to our calculator, turn it on at the bottom left, press the on button and then the y equals button, and clear out those equations. So we're going to enter 2 and then the upside down V button at the middle right, and then your variable button. So you should see 2 to the t power. Now you may still be in this area here, so you're going to have to use the right arrow key to get down. If you subtract 3 without pressing the right arrow key, then your 3 is going to be in the wrong place. You need to move over so that it's going to write 3 down here. Again, use the right arrow key for that. Then, again, 2 to the t power in the next equation. So you should have x1t is equal to 2 to the t power minus 3, and y1t is equal to 2 to the t power. So now we're going to press the window button, and your window should be -4 for x and +3 for x, and -2 for y minimum, and y max should be about 5. So x minimum is -4, x max is 3. Then we're going to graph this. Press the graph button at the upper right. And I want you to notice something that's pretty interesting. The graph did something like this, and then it just stops here. Oh, why does it stop? It should be a line that just keeps going and going. Why does it stop? Well, there are limitations to what the x and y values can be based on these equations. Again, that's the whole purpose for parametric equations. We're defining the equations using a third variable called the parameter. And so we'll see exactly why there's limitations. So first let's try 0 for t. So there's limitations for x and y, but there's no limitations for t for this particular problem. So x is 2 to the 0 power minus 3. Y is 2 to the 0 power. So x is y minus 3, which is negative 2. Y is 1. And so we have negative 2 comma 1. So let's plot that. Okay, and now let's choose maybe 1 for t. Try to choose the easier values if you can. So 2 to the 1 power minus 3 is x, and y is 2 to the 1 power. So x is 2 minus 3, y is 2. So our point is negative 1, 2. Okay, and let's choose another t value. So let's choose t is equal to let's see, we could choose maybe 2. So x is equal to 2 to the 2 power minus 3. Y is equal to 2 to the 2 power. So we have 4 minus 3, 4. X is equal to 1. Y is equal to 4. So 1 comma 4. So we have another point there. And you can see that this is kind of looking like a line. So now let's choose t is equal to negative 100. Now I know what you're thinking. Why in the world are we choosing negative 100? Well, you're going to see as we do this. So x would then be equal to 2 to the negative 100 power minus 3. Y would be equal to 2 to the negative 100 power. So what does it mean to have a negative power? Well, that means 1 over 2 to the positive 100 power. So remember, we learned that in my intermediate algebra course. That's just the definition of negative exponents. It's not exactly clear why that is true unless you go to the exponent rules. It's just a way to try to universalize the exponent rules. Now these values are really, really close to 0. In fact, you can just assume that they are 0. So this x value is going to be approximately 3, and this y value is going to be approximately 0. So again, those are only approximate values. So the point is going to be approximately 3 and approximately 0. I'm going to write approximately equal to symbols there. So that's excuse me, that's going to be negative 3. I'm sorry. That should be negative 3. So negative 3 is 0. It's going to be about there, but not quite there. It turns out that you can never reach negative 3 for x, and you can never reach 0 for y, but it's going to approach. So the line is going to approach the x-axis, but it's never actually going to touch. So why is that? Well, as x becomes a bigger and bigger negative number, or we should say smaller and smaller, these values just get closer and closer to 0, but they can never actually equal 0, because let's say you plug in negative 1000, well, that's just equal to 1 over 2 to the positive 1000 power. This is still a positive number. So you're never going to get to 0. Now, I know that that's difficult to think about, but again, it's all based on the definition of negative exponents. We learned about negative exponents in my intermediate algebra course. So that's why x and y are limited. Defining the values with these parametric equations gives us limits for x and y, and that's one of the benefits of parametric equations again. So now let's eliminate the variable. Now notice this is a little bit different because it's not going to be easy to solve for t. If you want to solve for t, you would actually have to use a logarithm. But we haven't reviewed logarithms, and we don't really want to review logarithms right now. We'll do that later on in the course. So we don't want to solve for t. But notice that y is equal to 2 to the t power. So can't we just plug in y for 2 to the t? I mean, what's wrong with that? Well, there's nothing wrong. We can just plug it in because we know y is equal to 2 to the t power, so there we go. Notice that the equation is the equation of a line. X equals y minus 3 is this graph. It describes the graph completely. But if you were to graph this equation down here, there's no limitations. So the graph would keep going down forever. But if you graph with the parametric equations, then the graph does have limitations. It has to stop there. So these are examples where t was not really limited, but because of the equations that we're using for x and y, the x and y values were limited. So let's do another example of that. So let's press the y equals button and enter these equations in. Sine t and 3 minus, and you're going to have to use a right parenthesis and then a sine t and then, excuse me, a left parenthesis and then 2 right parentheses and then the upside down v button and then the 2 power. So there's a lot of different ways you can do this. The calculator might have an exponential template somewhere, but I'm not sure where that is. So your equations should look like this. x1t should be sine t, and you can use 2 parentheses or 1 parenthesis. The calculator doesn't really care, but in the real world you need 2 parentheses. And then 3 minus parenthesis, another parenthesis, another parenthesis into the 2 power. So that's what you want to see. So now we're going to push the window button. And it's very important to understand that because we have trigonometric functions, your t values have to be considered degrees. So it's very important that you do this correctly. I'm going to enter negative 360 for t minimum, positive 360 for t maximum. That may be more than what we really need, but just to cover all bases. Now, I don't want a 0.1 degree step. That's too small. It'll take the calculator forever to graph that. So I want to change the t step to just 1. I don't want 0.1 degrees. I want 1 degrees. Everything's in degrees now because we're using trigonometric functions. So for x minimum, I want -4, x max is 3, same scale that we had before it looks like, except the y max should be 3, and the y minimum should be -4. So now let's push the graph button. If you don't enter in t values that correspond to degrees, then you're going to have some issues with your calculator. So t can be anything, but what you see is that the x and y values are restricted. You get something like this. The graph is supposed to go down like this, but it doesn't. It gets cut off. That's because these equations limit the x's and y values. So let's choose something that corresponds to degrees. We need degrees because we're using trigonometric functions. So let's choose 0 degrees. X is equal to sine 0 degrees. Y is equal to 3 minus sine squared 0 degrees. Sine 0 is just 0 if you recall. So we have x is equal to 0, y is equal to 3. So 0, 3 is our first point. So remember, 0 degrees corresponds to a collapsed triangle. I'm going to find a place to write this. So if you have a collapsed triangle, those result from quadrantal angles, 0, 90 degrees, 180, 270, 360. So if you look at your sine curve, sine 0 is just 0. The sine curve helps us to figure out the values for collapsed triangles, 90, 180, 270, 360. If you're rusty on that, you can go back to my trigonometry course. So you'll be able to review that. So now let's try t equals 90 degrees. I'm choosing 90 because the quadrantal angles are easier to calculate. So we have sine 90 degrees for x and 3 minus sine 90 degrees squared. So sine 90 degrees is 1. Again, that corresponds to this part here. That's 90 degrees there. That's 1. And so we have 3 minus 1 squared. X is 1 and y is 2. So the point that we're looking for is 1, 2. And now let's come up with another t value. Let's choose negative 90 degrees. X is equal to sine negative 90 degrees. Y is equal to 3 minus sine negative 90 degrees squared. So I'm going to move this over a little bit. So again, if you look at your curve, your sine curve, when we have quadrantal angles, it's best to use the sine curve. So this corresponds to negative 1. I'm making one whole, two blue divisions there. So we have x is equal to negative 1, y is equal to 3 minus negative 1 squared. So we have 3 minus 1, negative 1 squared is 1, and our point is negative 1, 1. So negative 1, 1 would be there. Actually, excuse me, that should be 2. Negative 1, 2. So, again, you see our graph is limited to that top part up there. So now let's choose, if we choose 180 degrees, we'll just get the same answers. So that won't really help much. But if we choose 30 degrees, that'll be helpful because sine 30 is just 1/2. We don't want to have to deal with roots if we don't have to. So x is equal to sine 30 degrees. Y is equal to 3 minus sine squared of 30 degrees. So that's just 1/2. And we have 3 minus 1/2 squared. And we're kind of out of room here, so we'll just calculate quickly. 3 minus 1/4 is 2 3/4. So 1/2, 2 3/4. So that'd be about there. So again, the graph looks like this and it just stops. So we don't want arrows because the graph doesn't continue down. So how do we know that sine 30 is 1/2? Well, you can go back to my trigonometry course, or the part of this course where we reviewed the trigonometry, and you can do some practice on that stuff. So now we're going to eliminate the parameter. It looks like we have an upside down parabola, but how do we know that? How do we know that it's an upside down parabola? Well, we can't really solve for t, because if we did that, then we'd end up with sine inverse of t, and we don't want to have to deal with that type of notation. We could, but some complications would arise. So what we're going to do is just rewrite this second equation, and instead of sine t, we're going to plug in x, because sine t is x. So we didn't have to solve for t in that equation, just like the previous equation. We didn't have to solve for it. So that is the equation, and you can see it's an upside down parabola. But this equation describes the entire parabola. The parametric equations only describe this part of the parabola. So that's very important to distinguish. Okay, so I want you to take a picture of these problems that we did. There are no limitations on t, but because of the parametric equations we're choosing, there are limitations on x and y in these particular problems. For number 13, you're going to have to change the t minimum and t maximum, the range for your parameter, because in the previous problem we had negative 360 and positive 360. So I want you to go to your window right now, push the window button, and change from negative 360 to maybe negative 10. We'll try negative 10 and see if that works, and then change the t max to positive 10. We're not going to use negative 360 and positive 360 because that would take forever to graph. Now we're going to change the step. We don't want the step to be 1. In the previous problem, the step was 1. We don't want that, because that's too big. In the previous problem, we were talking about degrees. 1 degree is a very small step. But if we're talking about normal units now, 1 degree, one is too big. So we're going to change to 0.1 for the step. And change your x minimum to negative 10, your x max to 10, your y minimum to negative 10, and your y max to 10. And then go ahead and enter those equations into your calculator, and be aware that you have to use the right arrow key to get out of the exponent, or else it'll add this 2 inside the exponent. So try number 13, and when you come back, we'll do it together. Okay, we're back. So if you graph this, it should look something like this. So let's find some t values. Again, t can be anything in these particular equations. There's no limitations on t, at least for these particular problems. Remember, in the previous problems that we did, there were limitations, but in this problem, there's no limitations for t. So x is 1 and y is 4. Our point is 1, 4. So we got that point. And now let's try t is equal to 2. So then x is equal to 3 to the second power. Y is equal to 2 times, and I just realized that that's going to be way too big, so we can't choose 2 for t. Let's choose 1. So x is 3 to the 1 power, y is 2 times 3 to the 1 power plus 2. So x is 3, y is 2 times 3 plus 2, which is 8. So 3, 8. That's going to be about there. And what else should we choose for our parameter? If we choose negative values for t, then we're going to get fractions, but actually let's choose negative 3 for t. So then x is equal to 3 to the negative 3, y is equal to 2 times 3 to the negative 3 plus 2, x is equal to 1 over positive 3 to the third power, y is equal to 2 times 1 over 3 to the third power plus 2. So that's 1 over 27, and y equals 2 times 1 over 27 plus 2. So the point that we're looking for is 1/27th and 2 and 2/27. So let me make some more room here if my computer will allow me there. It's going kind of slow. So 1 over 27 and 2 and 2/27. So that point is going to be about here. And what else can we choose? Let's try, well, there's not much we can really do, to be honest with you, because t can only range from about 0 to, well, it can go into negative numbers, but maybe we can choose 1/2. So x is equal to 2 to the 1/2 power. Actually 3 to the 1/2 power. And y is equal to 2 times 3 to the 1/2 plus 2. That's just going to be square root 3 and 2 square root 3 plus 2. So we don't really have to mark that on the graph, but it's obvious that our graph is just going to be, well, it's going to be a line. It's not exactly obvious why it's going to be a line, but we should have an arrow at the top because the graph actually keeps going, but no arrow at the bottom because it's not going to keep going at the bottom. It's going to stop because the parametric equations tell us that x cannot be smaller than 0. It can approach 0, but it can't be smaller than 0. And x cannot be smaller than 2, it looks like. It can approach 2, but it can never equal 2. So now let's eliminate the parameter. So we know x is equal to 3 to the t power. So why not just plug in x for 3 to the t power in that equation there, and we've eliminated the parameter. So in this equation, the graph, if we graph this equation, it graphs the entire line. But if we graph the parametric equations, it only graphs part of the line. So for number 14, we're going back into trigonometric functions. So press the window button, and for t minimum, you're going to enter negative 360, and for t max, positive 360, just to be safe. That might be more degrees than you really need, but change the step to 1 degree, not 0.1. And then change your minimum x to -4, your max x to 3, minimum y to -4, maximum y to 3. And then press y equals and enter your equations. So try 14. Make sure you have the right number of parentheses when you use your exponent. When you come back, we'll do it together. Okay, we're back. So x1 t you're going to need a parenthesis, a left parenthesis, and then the cosine button, and then a variable, and 2 right parentheses. So it should look like this. All right. Then you go down to the next equation, and you're going to need a right parenthesis. So your equation should look like this. All right. And then we're going to press graph. And there's our graph, and notice that it seems to be cut off. So the graph looks something like this. The reason it's cut off is because x and y are restricted. T is not restricted, but x and y are restricted. So let's start by choosing 0 degrees. Why 0? Well, because we have trigonometric functions. So cosine 0, if you recall, is actually 1. So we have 1, 2. So that's 1 point. And how do we know that cosine 0 is 1? Because if you look at your cosine graph, 0 degrees is here. That corresponds to a value of 1. So let's try t is equal to 90 degrees. We want to stick with quadrantal angles if we can. Just makes things easier. So cosine 90 degrees is 1, so we have 1 cubed. Remember, that's the same thing as cosine 90 degrees cubed. So we have 1 plus 1. Wait, excuse me, it's 0. 0 plus 1. Cosine 90 degrees is not 1, it's 0. I think I said 1, I meant 0. So the point is 0, 1. So we have another point there. So now let's choose negative 90 degrees. Again, we're trying to stick with quadrantal angles. And y is equal to cosine negative 90 degrees plus 1. Let me make some more room here. Sorry, my computer's going kind of slow. So x is equal to, that's going to be 0 again. Y is going to be equal to 0 plus 1. So it looks like we actually got the same exact point. So that happens sometimes. That's okay. So we need to choose something else for t. Let's choose 180 degrees. So x is equal to cosine cubed 180. y is equal to cosine 180 plus 1. So cosine 180 is negative 1. Negative 1 plus 1. So x is equal to negative 1. Y is equal to 0. And we have another point. Negative 1, 0. So negative 1, 0 is here. And let's choose one more value for our parameter. If we choose negative 180, we get the same values we got for positive 180. So cosine is 1/2 when it's 60, when the reference angle is 60 degrees. We can just try 60 degrees, I guess. So x is equal to cosine cubed of 60 degrees. Y is equal to cosine 60 degrees plus 1. So we have 1 cubed, and y is equal to, 1/2 cubed, and y is equal to 1/2 plus 1. So we have 1/8 and 1 1/2 if you want to use the mixed number. So 1/8 and 1 1/2. So that would be about here. So those are our points, and now let's try to see what this graph is going to look like using if we eliminate the parameter. So we can't isolate t very easily, but we can isolate cosine t. We know cosine t is equal to y minus 1. And then we can just plug in y minus 1 in the other equation. And we see we have a cubic. So if we look at our calculator, we see that the range is restricted. So we can't use arrows. And the reason that we have restrictions is because cosine is limited to values between negative 1 and 1. And so the smallest y value would be 0, and the biggest y value would be 2. So if you graph this equation down here, you get the full cubic function in both directions. But if you graph the parametric equations, you have limitations. So if you got that right, excellent. I know it's hard to find points that work easily, but if you got that, good job. So now we're going to do some special problems. Let's go to your calculator, y equals, and enter in our trigonometric functions. X is cosine t, y is sine t. And then we're going to go to the window. We're going to change the window to negative 2 and 2 for x and negative 2 and 2 for y. And we're going to graph this. And if you're using a TI-84 Plus, for some reason it doesn't make the horizontal units and the vertical units the same on the graph. So it looks like an ellipse, but it's not an ellipse. It's actually a circle. And we're going to see why that is. So first let's plug in 0 degrees. So x is cosine 0 degrees, y is sine 0 degrees, x is 1, y is 0. So we have the point 1, 0. And now we're going to plug in, say, 90 degrees. And we see that x is equal to cosine 90 degrees, y is equal to sine 90 degrees. So x is equal to 0 and y is equal to 1. So the point is 0, 1. So we have another point there. Now let's choose x is equal to negative 90 degrees. So x is equal to cosine of negative 90 degrees. And y is equal to sine of negative 90 degrees. So cosine negative 90 is 0, and sine negative 90 is negative 1, so we have a point 0, negative 1. So you can see that this is actually going to be a circle. It's not an ellipse. So let's choose 180 degrees this time. So cosine 180 degrees is x, and y is sine 180 degrees. So cosine 180 degrees is negative 1, sine 180 degrees is 0. So we have negative 1, 0 as our next point. Alright, so then we're going to draw that graph, and you can see that it's a circle. Now here's the part where things are going to be quite different. We want to eliminate the parameter, but if we try to solve for t, we can see that we're going to end up with inverse trigonometric functions, and things start to get complicated with inverse trigonometric functions. So we don't really want to do it that way. We're going to use a special method. You need to be aware of this method when you're working with parametric equations, because you're going to see this a lot. We need to use a Pythagorean identity. So maybe I should bring that identity down here. Well, I'll just leave it up there for now, I guess. So we're going to write the Pythagorean identity. As long as the angle is the same in both of these functions, the angle variable, then this identity is always true. So in this case, we have the same variable in both equations. So we can actually use the Pythagorean identity. I know that seems weird, but this is always true for the trigonometric function cosine and sine. Always true, as long as those variables are the same. Okay, and they are in this case. They're both t. So we can replace. Now, before we do anything, actually, I'm going to just remind you that this is abbreviated notation, which means this. So don't be confused by that. So sine t is just y. So I'm going to replace with y, and cosine t is just x. So then we have y squared plus x squared is equal to 1. You can see that it's just a circle with center at 1. So that's how you eliminate the parameter when you have functions like that. It's the easiest way to do it. There are other ways to do it, but that's the easiest way, using this Pythagorean identity. So I know that seems like a dirty trick, but that's just the easiest way to do that. So now let's go to number 16 and enter these equations in to our calculator. And the window we maybe need to change it a little bit. So let's go to the window, and our minimum x is going to be, looks like -7, +7, -7, +7 for the y min and y max. We're going to graph that, and we get some sort of a parabola. Actually, we're going to get an ellipse. So the ellipse is going to look something like this. So as usual, let's find 4 points. So we're going to plug in 0 degrees first. So x is equal to sine, or 3 times sine, (0 - -2). Y is equal to cosine 0 degrees plus 1. So we have 3 times 0 - 2, and 1 plus 1. So the points are going to be -2, 2. Or the coordinates are going to be -2, 2. So that's about there. And now let's plug in 90 degrees for t. So we have 3 times sine 90 degrees minus 2 and cosine 90 degrees plus 1. So x is equal to 3 times 1 minus 2. Y is equal to 0 plus 1. So we have 1 comma 1 for the point there. Now let's try plugging in -90, and if the t value doesn't work, we can always try something else. So x is equal to 3 times sine -90 minus 2, and y is equal to cosine -90 plus 1. And so x is equal to 3 times -1. If you look at your sine curve, we have 0 plus 1 again. So x is -5. And y is 1. So -5, 1 would be about there. And what else can we choose? If we choose 180, we'll get -2, 0. So that looks like a good point, or good parameter. 180 degrees. So x is equal to 3 times sine 180 minus 2, and y is equal to cosine 180 plus 1. So let's do the math. So x is equal to 3 times 0 minus 2, y is equal to -1 plus 1. So we have -2, comma 0. So it looks like our ellipse looks like that. All right, if you got that right, good job. So again, we have to use our special trick, our special identity, to eliminate the parameter. We know that sine squared t plus cosine squared t is equal to 1. But it's going to be a little bit more involved when it comes to eliminating the parameter in this particular problem. We're going to have to solve for sine t first. So I'm going to add 2 to both sides, and then I'm going to divide both sides by 3. And the other side, or the other equation, I'm going to simply subtract 1 from both sides. So at this point, I'm then going to use the Pythagorean identity. And so I'm going to write the identity and just plug in what sine t is equal to. Isn't it true that sine t is equal to this? So I'll just plug that in, x plus 2 over 3 squared. And isn't it true that cosine t is just y minus 1? So I'll plug that in. So I think I'm just going to eliminate this step. You can probably do that algebra in your head. So then we're just going to simplify, and we get, let me shrink this a little bit. So we get x plus 2 squared over 9 plus y minus 1 squared equals 1. So we eliminated the parameter, and you can see that this is probably familiar. That's actually an ellipse. And a is equal to 3 and b is equal to 1. So a is 3, b is equal to 1. So a is 1, 2, 3, b is equal to 1. And the center is negative 2, 1. You can see it's the same center. So again, you have to use your Pythagorean identity. So you're going to need that. So go ahead and try number 17. And when you come back, we'll do it together. So we eliminated the parameter. So I want you to try one more problem like that. Attempt number 18. When you come back, we'll do it together. So we eliminated the parameter, and there you go. So now, to finish this class, we're going to do one more thing. We're going to create parametric equations. So we're going backwards now. So we have an equation that is not dependent on a parameter like t. But we can create parametric equations. Let's say that x is going to be equal to t. Then y would be equal to t squared plus 4t minus 1. So we've done it. We created parametric equations. That's the easiest way to do it. Now in this case, it's going to be easier to let y equal t, because we don't want to deal with a root symbol. Then x would be equal to t cubed. So there you go. We have more parametric equations there. You can see that this is pretty easy. So here, let's let x equal t again, and then we see y plus t is equal to 4, y plus 2 is equal to 4 to the t plus 1. And just to make things look nice and neat, let's solve for y in the second equation. So there you go. So as you can see, creating parametric equations is not very difficult in most cases. So try number 22. When you come back, we'll do it together. Alright, we're back. So I'm going to let x equal t, then y equals 1 over 5t. So now we have parametric equations. Okay, go ahead and try 23. When you come back, we'll do it together. Alright, we're back. So I'm going to let x equal t, and y is equal to 3t squared over t. So pretty easy. So for number 24, you want to let y equal t. If you let x equal t, then you'll have to use a logarithm to solve for y. So let y equal t, try 24. When you're done, we'll do it together. Alright, we're back. So again, you want to let y equal t, then x is equal to 2 to the t power. And there you go. So in these problems, we were just going backwards. So that was the class today. If you'd like to take screenshots of the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, and number 10. Don't go before you get your homework. Remember, the homework is not optional. Here's screenshot number 1 of your homework assignment, and screenshot number 2, and number 3, number 4, and number 5. But don't go before you get the answers. Remember, it's not enough just to attempt the homework, it must be done correctly. So you need to verify that your work is correct with these answers. Here's screenshot number 1 of the answers, and screenshot number 2 of the answers. So get that homework done completely and correctly and neatly, and keep it in order in your binder, and I'll look forward to seeing you in the next class.